Hello, everyone, and welcome to today's lesson, Science Prodigy Session 25, Natural Disasters Part 3. If you are new, I'll talk to you about what our rules are. For example, our main rule is to use proper etiquette, which means always to use manners. And if you need something, you can always type it in the chat, such as a question, you always type it in the chat. But if you want me to call on you faster, you can also raise your hands as participants. Our classes start off with a warm-up. We review our warm-up and then go on to the lesson. Today's lesson is Natural Disasters Part 3. And after the lesson, there'll be a short quiz and then a fun game or demonstration. Okay, for today's lesson, Natural Disasters Part 3, you can begin with the warm-up. So you can do one of the warm-ups for either the flood or the tsunami, which we learned in our last class, Natural Disasters Part 2. So our floods warm-up is what type of flood is the most destructive, name a way that helps to prevent flooding and how it helps. And our tsunami warm-up is name 4 things that cause tsunamis and name the parts of a wave. Okay then, so you can begin the warm-up and I'll give you guys 3 minutes and then we'll review our warm-up. Okay guys, let's look at your answers. So if you have an answer for the floods warm-up, please raise your hand in the chat so I can call on you. Okay, so let's start off with Aryan.
Okay, so the type of the flood that's most destructive is a flash flood, and a way that we can help prevent flooding is like plant more vegetation because it soaks up water and gives plants moisture and gives plants water and moisture to the soil.
Perfect. That's it. That's correct. The type of flood that is most destructive is in fact the flash floods. And planting more vegetation is a way to help prevent floods because it does soak up water and it keeps the soil in a stable place and it keeps a bond. Okay, what else you could have said to prevent flooding are sea and coastal defense walls. For example, off the coast of Netherlands, they have lots of walls to make sure that it doesn't get flooded, and it is almost below sea level. So without those walls, the whole city would be flooded of Amsterdam. Okay, and for the tsunami warm-up, if you have an answer for the tsunami warm-up, please raise your hand in the chat. Okay, Shrivan.
Yes, four thing like tsunamis or waves are caused by sudden movement of the ocean surface due to an earthquake, landslide on the sea floor. Landslopes, uh, and large volcanoes, anything under the sea which causes a movement in the ocean could cause tsunamis.
Perfect. So you did name 3 of the main things, volcanoes, earthquakes, and landslides, and mainly anything underwater that is a big natural disaster. But our 4th one is a very rare one, is a rare meteorite strike, as it does cause large tsunamis. But that's a rare thing. It won't happen soon because we have scientists looking up to make sure if we have one. Okay, so does anyone know part 2 of the tsunami warm-up? Name the parts of a wave. Okay, Harika, do you have an answer?
No, I forgot to put my hand down. I only have an answer for 2 ways to prevent flooding and two things that make a tsunami.
That's okay.
2 ways to prevent is high houses and walls and dams, and two things that will make a tsunami is an underwater volcano and earthquakes.
Perfect. That works. That are some things that cause tsunamis and a way to prevent floods. But to prevent floods is dams. But what you said, making houses higher up, that's a way to make sure that the damage is less. It doesn't stop floods, but it is a good way to make sure damage is less, as floods do occur on the bottom. So good job on adding on that. Okay, name the parts of a wave. That's okay. I can just answer that for you guys. The parts of a wave, because a couple of you did answer it correctly in the chat, but for those who just want to watch and want to learn more, our parts of our wave include the wavelength, the crest, trough, the wave height, and the wave amplitude. So I'll quickly draw it fast. So we have our wave here. And here is sea level. This is sea level. So this is the wavelength between two crests. So our crest is the topmost part. This is a crest. These are crests. And our trough are the bottommost parts. This is a trough. This is a trough. And our wavelength is between two crests, the distance between two crests. And our wave amplitude is between the crest and sea level. And our wave height is between the crest and the trough. Okay, then let's move on to today's lesson, Natural Disasters Part 3. Okay, so introduction, which starts off with landslides and mudslides. Like the other natural disasters, landslides and mudslides are one of the most powerful and destructive natural and environmental events. They come almost when no one expects them, and they can occur and destroy things in a very short space of time. They are also known as landslips, slumps, or slope failure. A landslide is a massive movement of rock, soil, debris, or earth material downwards along a hill or slope due to the force of gravity. The movement may be flowing, spreading, falling, toppling, sliding, and so on. This can be dry debris movement or water saturated, which is the muddy earth material. Landslides can be found all over the world, including every state in America. They can occur on every type of surface, whether rocky or sandy, and also happen both on land and underwater. There are many causes of landslides, some natural and some man-made. The biggest reason for a landslide is always that there is a slope and material goes down the slope because of gravity. But other things that contribute to landslides include erosion by rivers, glaciers, or ocean waves, which makes the slopes too steep, rock and soil, slopes made weak through saturation by snowmelt or heavy rains. We have earthquakes, which create stresses that make the weak slopes fail. We have volcanic eruptions, which produce loose ash deposits, heavy rain, and debris flow. We have vibrations from machinery, traffic, blasting, and even thunder, which may trigger failure of weak slopes. Weight from much rain or snow, stockpiling of rock or ore, from waste piles, or from buildings may stress weak slopes to fail, and other structures. We have groundwater pressure, which makes the slope unstable, and it's in shallow soils, the removal of deep-rooted plants that bind the collivium to the bedrock causes landslides as well, because that bond to keep it in place is gone and it's free to cause a landslide. How do they form? Whenever there is a natural disturbance or instability in a piece of land, on a hill slope, mountain, or generally upland area, there is a potential for a landslide. This is because the earth material or of the hill or mountain is held in place by the natural bonding of the material and the gravity acting on it. This means that when the earth material loses its bonding, either through weathering, erosion, or too much water in the bedrock, the weight of overlying rock will give away and gravity will pull the earth downhill. Okay, so in figure A, the hill was held in place by its natural bonding. After too much water in the earth, the bonding is broken up and the earth falls, which is in figure B, due to gravity. Natural disasters such as floods, earth movements, which is when the earth trembles, earthquakes, and volcanic activity, can also set off landslides, as they all have the potential to break up earth material. So if we see our diagram in figure A, we have our slope, which is saturated surface with rock or earth bonding broken. So it's still okay, it still has the bond, but once after a couple of hours, or depending on how much the earth has unsaturated, the material will fall in and collapse on itself and float downhill. Causes of landslides. One of them is slopes saturated by water. Intense rainfall and snowmelt and seepage often leave land surfaces saturated. Flooding results and water overflowing its channels often wipe out land surfaces to cause mud flows. Seismic activity is another one. Earth's tremors, earthquakes, and natural seismic activity that cause the earth to rumble or shake, which are like vibrations, can weaken the bonding of bedrock and expose the earth to landslides. We have another one, which is volcanic activity. Lava from eruptions has the potential of melting snow at a very high rates. A combination of melted snow, debris, volcanic ash, and soils flowing rapidly along the slope can result in catastrophic landslides. We also have a geological cause, which is weathered rock, sheared rock, fissured rock, or jointed rock material that are known causes of landslides. Okay, let's move on. So, causes of landslides. So we have two main categories. We have human causes and we have morphological causes. And in our first category, so you can think of morphological as natural. So in a natural cause, we have all forms of erosion, such as fluvial water, wave, glacial, and along a slope may cause landslides and other types of flows. Deposition from erosion may also cause buildup of earth material or debris at places, which may eventually give way in the form of landslides. Weathering is also a major cause of landslides. It is a powerful process of weakening debris and earth material of the surface of the slope. Man-made and human ways include activities such as mining, construction, farming, deforestation, irrigation, reservoirs, and dams, and all contribute to exposing the surface of Earth and causing landslides. For example, in many mining communities along slopes, tunnels and deep wells are dug into the ground and left often unfilled. With time, air and water get in, which may result in the earth giving way. Such activities also expose lands to weathering and massive erosion, which all end up causing some types of landslides. So in the chat, I would like everyone to type one cause that humans cause landslides. Not including these. So we do remember that landslides are caused by exposing the surface of Earth, which causes landslides. So not mining, construction, farming, deforestation, irrigation, reservoir, and dams. I would like anyone to type in the chat an example which is not stated down below. Okay, so a lot of your answers are correct, but I think a couple of them are really good answers. So one of them is really common, which is digging underground for subways. I really like that one because making subways means creating long, big holes. But sometimes if it's created on a high elevation city, then it can cause landslides to the elevation lower. Too much traffic activity is one of the examples as well, because by doing lots of traffic and lots of vehicles, not only does it give pollution, but it also causes a lot of wheels, and the pressure on top of roads can, if the roads aren't strong enough or a bridge isn't strong enough, it can cause landslides. For example, there are bridges over on top of valleys, which are connected by two sides of a mountain. And if the bridge is not stable by the amount of cars and other vehicles on top, and it might give in. And with that sudden cause of collapsation, the sides will also experience a big landslide as well. Because not only do the bridges hold a barrier and boundary between two sides, but it can also help to keep the side stable and in a connection. So as we talked before, there's a bond, because if this bridge, sometimes the bridge has cut through roots of trees or specific parts of the soil, which is bonded with other parts. And because the bridge is there, it can help to keep the bond going. But if it does collapse, bonds will break and soil can just give in as well. Okay, then let's move on. Types of landslides now. The types of landslides are usually differentiated by the nature of its movement and earth material involved. Our first type is a slide. Slide may be translational or rotational. In a translational slide, the earth mass is largely in place after it slides downhill on a plane per face. In a rotational slide, the movement of the earth material is rotational in nature. It is also known as slump. So if we can see in our first one, transitional, it's just that these were connected, but they just gave in and they just broke apart and just slid it down. But our top part is still have a bond with the bottom, probably because vegetation is still has its roots stuck inside the soil, which is good, like an anchor. But this bottom part might have lost its bonds and might have just slopped off. But our slides are rotational slump. It was there, but because of the intense gravity, it just slumps from one side, but there's still bonds over here, but it used to act like this, and these bonds were broken and couldn't keep its weight in. So it just fell down this way, but it created this small area to grow a little bit higher. So starting off, it might have been this tall, for example. So our hail might have been maybe around this tall or this type of slope. But after this area had just given up with its bonds, it might have caused a high rise in the area up here, which is why we can see it's a slump, because some part of it is bonded together, but other parts aren't. Oh yeah, by saying bond, I'm not meaning like in chemistry, because that's too advanced, but bond is just like the roots in the soil are connected in a way that it holds the roots in place like an anchor. Okay, another type of landslide is a topple. In a topple, the earth mass rotates forward about a pivot. This results in a tilt without collapse. It is usually caused by cracks or fracture in the bedrock. In our first figure, we have a picture of a topple, and as we see, it used to be standing apart, most likely just in a figure that has a from the edge to edge in a straight line, a horizontal straight line, no slant, no angle, just 0 degrees. But what might have happened is that these bonds not only may have broken, but this one back here, like dominoes, might have just fallen, but all of these were still in place, and that creates extra weight on top of this that's like a domino effect. And with the energy traveling, we have more energy traveling on here. So if we have just the energy of one rock falling on here, now we have the energy of 2 rocks and 3 rocks and 4 rocks. And eventually all of the rocks will fall down if the last rock is small enough to be toppled off. And that's usually a topple landslide because it just rotates forward to form a pivot because it's still holding here. This is where it originally was, but it's just that it was more tilted this way. But now when it turns, it stays in place with the bond, but it's just that it's tilted. Now we have a fall landslide. These are usually influenced by gravity after large rocks or boulders are detached from their parent rock. They usually fall along steep slopes or cliffs. Now in this picture, in this figure, we clearly see that none of this big parent rock had lost its bond. It's all stable. It's just that if we can guess how it was before, it was probably something like this. And we see that there's nothing holding it. And if it had too much weight, it just falls off, influenced by a strong amount of gravity as well, which is a big reason that this fell off, but none of the other part of the parental figure fell off. Next, we have our flow. Flows come in many types, such as a debris flow, debris avalanche, mud flow, creep, and earth flow. Debris flow involves a rapid downhill movement of loose earth material, usually with water. Debris avalanches are similar to debris flow, but they have a more rapid flow, faster. In an earth flow, the earth material is finer and washed away, leaving a depression bowl at the head. Mud flows are made up of fine silt, sand, clay material saturated with water and flowing very rapidly. Creeps are slower in nature and can be evident when electric poles and roads bend slightly. So in our first figure, we have our creep, and we see that it is falling. It's like a landslide, but it is slow, and it's not causing tiny pieces. There's still this parental figure, the whole parental figure just detached. In our second one, in just a normal flow, we have this, it just disattaches itself and just lets it go down. And in our debris flow, it's just a rapid movement, just falling down from our top of our mountain or a slope, but it does include water, usually with water. So here's our diagram of our landslide. So you won't need to know every single one of these parts, but we'll talk about our main parts in our next slide. But what we do need to know for sure is that in our first figure, we do have our normal landslide. It has occurred, but what has happened is that only this part is collapsed. The outer layer still has its bonds all around, but it has collapsed and has created a depression right here. But the rest of it that was collapsed here just piles up over here. So our parts, we'll only talk about the most important ones later on. So in our second one, we have our source area, which is where it used to be, our main track, the where it went, and the depositional area, which in depositional, we find the word deposit, which means where it deposits, where it ends up, where it's put after all of that. Okay, next slide, move on. What are the effects of landslides? Nobody can outrun an approaching landslide or mudflow. They're so fast and powerful that they wipe out trees and rocks in their way. They can cause massive destruction in many ways, such as loss of lives, destruction of property, economic cost, and destruction of natural environment. So out of all the times landslides have occurred, what is the biggest one that is? The world's biggest historic landslide occurred during the 1980 eruption of Mount St. Helens volcano in the Cascade Mountain range in the state of Washington, USA. The volume of material was 2.8 cubic kilometers. Now, if you guys remember from our volcano lesson, our first natural disasters lesson, which was 2 classes ago, we talked about Mount St. Helens a little bit. But we talked about how volcanoes can cause big landslides because when they do erupt, they create tremors, which are like movement of earth, and they also cause large seismic activities, which can cause this bonds to get very loose and shaky, and also can cause the loose materials just to fall off. Now for our second natural disasters, it's the mudslide. What do you call it when a huge flow of mud travels down a slope? Of course, a mudslide. Mudslides occur when a large amount of water causes the rapid erosion of soil on a steep slope. Rapid snowmelt at the top of a mountain or a period of intense rainfall can trigger a mudslide, as the great volume of water mixes with soil and causes it to liquefy and move downhill. A mudslide, also known as mud flows or mudslides, is a fast-moving landslide, usually along a channel or canal. When they occur, they may cover a very small area, uphill to downhill, or may travel over several miles from their source. A mudslide can vary from very watery mud to thick mud, with tons of debris, including large boulders, trees, and even cars or houses. Depending on the volume and speed, it can wipe out anything in its path, such as houses, cars, trees, and electricity poles. Okay, so if you have ever stepped in mud, you'll know that it can be very thick and clingy. It might be hard to imagine such mud rushing downhill at a great speed in order to do much damage. But mudslides contain a lot of water and thus act more like a flood than like landslides. Mudslides have been known to rush downhill at speeds of 50 miles per hour, laying waste to everything in its way. When discussing mudslides, experts will use special certain terms, including main scarp, shelves, and the toe. So if we look back at our landslides and mudslides have pretty much the same parts. It's just how they work, because mudslides are mud and landslides include rock and debris. But they can occur differently. So they have pretty much the same parts. We have our main scarp, we have our chute and shelves, and we have our toe. The main scarp is the original area where the mudslide began. The toe is the last area affected by the mudslide, where it ends. And shelves are the area where a mudslide path crosses hills or natural drops, creating large dips. A large mudslide can have multiple shelves. So our chute is the area containing all of our shelves. So our main scarp starts at our top, which is usually the topmost part and the highest elevation of our mudslide, because mudslides and landslides, most of the slides that we are talking about in today's lesson, they will go from high elevation to low elevation. Our main scarp is the starting point of our mudslide. Then in our initiation zone where it finally begins, it goes through our chute, which contain our shelves, large dips, for example, including large changes of elevation, because different areas which have different bond strengths will often have different effects of mudslides. For example, if an area has a very loose bond compared to an area which has a very strong bond, for example, if this area has a very strong bond compared to this loose bond, then probably there'll be a depression here or a deeper depression here rather than over here. And lastly, we have our toe, which is kind of like our end of our mudslide, the bottom part. Okay, let's move on. Now, our last natural disaster we're talking about today is our avalanche. An avalanche is a phenomenon of nature linked to snow. When there is too much snow on a mountain, some of the snow may fall, causing damage to things in its path. This is called an avalanche. Avalanches may be dangerous to skiers and other people doing winter sports. Large avalanches may carry stones, boulders, and trees with them. They may bury people under them, for example, skiers, are the most vulnerable. And if the people are not found rapidly enough by rescue teams, they will die of suffocation, not getting enough air, or hypothermia, which is freezing cold. Okay, so what causes avalanches? What causes avalanches? Okay, so one of our main causes of avalanches are overloading. And overloading is an important trigger. The weight of the snow increases until it overcomes cohesion to the snowpack underneath. So it's pretty much that the weight of the snow on top of a mountain just becomes too much for the bottom part, for the snowpack underneath to handle. So just falls, just like overloading. Temperature has an effect on cohesion of the snow as well. A rise in temperature weakens the bonds, creating weakness, while a fall in temperature increases the brittleness and tension of the slab. Slope angle is important as most avalanches occur on slopes between 25 and 400 C, which is our slope gradient. Although avalanches have been noted on slopes as gentle as 150 and steep as 600. Snowpack conditions is a significant factor as the layers below the upper snow cannot be seen, and it is difficult to assess whether the slope is likely to fail or not. Vibration is a physical trigger caused by thunder, a gunshot, by explosions, or other loud noises, such as shouting. Earthquakes can start avalanches as well as noise from heavy machinery. But of course, shouting won't cause an avalanche unless you have an extremely loud shout or it's a group. So how is it formed? The temperature in the top layer of snow decreases or increases. Both of them work. The layer of the snow closest to the ground maintains its temperature, causing a temperature difference between the upper and lower layers of snow. So if, for example, the temperature is the same here as it is here, for example, if both of them decrease, then as we talked before in our previous one, we talked how if the fall in temperature, it causes brittleness and a tension in slab. If there is a tension here, there's also a tension here, right? So by pushing more on this, that also means that this whole thing will collapse. But of course, there is this center part which holds both areas compacted together. So if there is a difference between the upper and lower layers of snow, it is causing a higher chance that an avalanche will be formed. Evaporation begins to occur in the lower layers, disrupting the stability of the snow above. And the upper layers of the snow lose grip and begin to slide, causing an avalanche. Where can avalanches occur? Mountainous areas throughout the Arctic and temperate regions which have slope angles between 25 degrees and 60 degrees are at risk. The avalanche problem is a severe problem in Europe rather than North America due to the high population densities in the Alp mountain range, which is between Switzerland and France and Italy. So what are the types of avalanches? We have slab avalanches. The most common type of winter avalanches is the slab avalanche. It is due to the buildup of fresh snow. A slab is a compact snow surface layer that can detach from a weaker snow layer underneath. The slab slips forward as a whole block or breaks into pieces. Loose snow avalanche. Loose snow sliding down a mountainside is called a loose snow avalanche. Small loose snow avalanches are called sloughs. Icefall avalanches. When glaciers flow over a cliff, they form the ice equivalent of a waterfall, an icefall. Falling blocks of ice create an avalanche of ice, which often entrains snow below it or triggers slabs. Especially in big mountains, icefall avalanches can be large and travel long distances. Glide avalanches occur when the entire snowpack slowly slides as a unit on the ground, similar to a glacier. Cornice fall avalanches. Cornices are the fatal attraction of the mountains. They are elegant and cantilevered snow structures formed by wind drifting snow onto the downwind side of an obstacle, such as a ridgeline. Similar to an icefall avalanche, the weight of a falling cornice often triggers an avalanche on the slope below, or the cornice breaks into 100 pieces and forms our own avalanche, or both. Wet avalanches occur after a warm spell or during the spring thaw. Snow becomes heavier as it begins to turn into water. It occurs frequently and are generally smaller and generally easier to predict than the other types. Slush avalanches usually occur in the very northern latitudes, such as the Brooks Range of Alaska or in northern Norway. They are unusual because they occur on very gentle slopes. So here are our 7 avalanche problems. We have storm or snow. We have our deep slab, a wind slab, wet avalanches, persistent slab, loose snow, or a cornice fall. All of these are examples of avalanches which can be occurring. An avalanche occurs when a large mass of ice and snow breaks away from the side of a mountain and surges down the mountain, which prevents speed and force. Some avalanches are small and only a minimal amount of snow moves down the mountain. When this occurs, it's called slowing. Most avalanches are triggered by people skiing, snowboarding, hiking, or snowmobiling on top of the snow. Avalanches kill more than 150 people throughout the world each year. When a slab of snow begins to move down the mountain, it can reach speeds of 80 miles per hour, which is 130 kilometers. Most avalanches occur within 24 hours after a storm drops 12 or more inches, which is about 30 centimeters of fresh snow. Other areas that are extremely vulnerable to avalanches are where layers of wind-driven snow has accumulated. People in mountainous areas protect themselves from avalanches in several different ways. Special fences help to hold snow in place. Barriers help to stop sliding snow or change its direction. Explosives help to clear snow from places where avalanches are likely to occur. Skiers or snowboarders are encouraged to wear an avalanche beacon, so if they are trapped, the rescuers will be able to find them. Okay, then that was today's lesson. I will post the link to the quiz in the chat, and you can take the quiz. After the quiz, we will not only go over the quiz, but we will also, we have a game / demonstration today as well. Okay, then I'll post the link. Okay, guys, so if you are in the middle of the quiz, you can turn off your audio so you don't hear the answers. And after you finish the quiz, you can come back. But if you have finished the quiz, let's go over it. So what's our name? Class. So what is a landslide? So a landslide, erosion of riverbeds when large vibrations occur. No, that's not right. Huge flow of dirt and mud traveling downwards. That's a very, very basic definition of possibly a mudslide, because in a landslide, it includes rocks and not much of mud. A massive movement of rocks, soil debris, or earth material downwards along a slope. That's correct. Which of the following does not contribute to the cause of landslides? So pollution and plastic doesn't, because it has nothing to do with landslides. The removal of deep-rooted plants does helps to cause landslides. Same does loud and very high vibrations and other natural disasters. Which of the following is a potential point? As we talked before, landslides occur from slopes, so the only place here with a slope is a volcano. Which of the following breaks natural bonds in the ground? So that's That's seeping water because of course. Okay. So of course, to break natural bonds, the one that breaks natural bonds of all of these are seeping water. Tremors are mostly related to earthquakes. Which of the following is not a morphological? Remember, that's basically natural irrigation, what we irrigate. Now, this one, a couple of you guys got wrong. So look at the size of our rocks and our mountain next to it. So if we go back to here, let's see how our landslides are. We can already cross out flow because it's definitely not a flow. But if you guys can see carefully, our topple still remains where it was. It doesn't fall off the slope. But in a fall, it actually gets off. It's a big rock, but usually it's just because of, in topples, it's just because of cracks in the earth. But in falls, it's big boulders that fall off. And in topples, they also keep their position. So that's actually a fall. Hope you guys understand why. Okay, next. How do mudslides work? Mudslides, we already know that mudslides are caused by water and soil mixing. So it's this. We already know that landslides getting rain. So a lot of rocks getting rained upon causes it to change into mud. That doesn't make really a lot of sense because rocks cannot change into mud that fast with rain because they are traveling downhill. So that's not a mudslide. A large body of snow melting at the same time. Okay, we already know that's wrong because mudslides are not always caused by snow. And aquifers overflowing, that usually doesn't happen because of course our soil will just seep it in and plants will also just take it in from the roots. What is the toe of our mudslide? We already know from top to bottom. Our top is our main scarp. Our shells are the middle and our toe is the last area, which is not a way people can die due to an avalanche pressure under snow because, I mean, they can, but it's mainly because of suffocation and hypothermia. By getting under the pressure of snow, you don't necessarily die. You'll die because you don't have enough oxygen to breathe. You can just dig yourself out. Hypothermia means it's too cold for you to survive. What type of avalanche occurs when an entire snowpack slowly slides as a unit on the ground? So that's a glide avalanche. And in each row, select what is true and what is false, about what causes avalanches. Avalanches can only occur on steep slopes. False, because we already know that avalanches can occur on very flat slopes, but it's still a slope. So even if it's not that steep like this, but it's still like maybe even like, I don't know, 15-degree angle, very small avalanches can occur in small and very slow, but they can still occur. A fall in snow temperature does not cause avalanche. False. A fall or rise in snow temperature will cause an avalanche. Could cause an avalanche. Loud noise from machinery sometimes causes an avalanche. True. Avalanches by too much weight is called overloading. A rise in snow temperature weakens the bonds. True. Vibrations from gunshots cannot create avalanches. That's false. They can if they are extremely loud. And knowing the conditions of a snow helps to prevent the avalanche. True. Let's quickly make sure we have everything correct. Okay, so we have everything correct for today's quiz. So now that we make sure that you guys understand, if you did get something wrong, I will quickly stop sharing my screen, and I'll tell you guys who got the best 100 or so there about nobody got 100%. That's okay because it was pretty hard quiz. But a lot of you got within the 10. So I'm going to just call out your name if you got 14 and above. So Kartika, you got a 17. That was one of our highest. Good job. Cole got a 15. I'm just going to read out the names now. Saheli, Adam, Renel, Ryan, Aryan, Kamlesh, Shrivant, and Kartikeya. Oh wait, I'm not finished. Kartikeya and Vishnu. Now, the person who got a highest in our class, that was an 18. So that's Kartikeya and Aryan. Good job to both of you for getting the highest scores in today's lesson. Round of applause over computer. Good job to you both. So now that that's finished, let's do today's demonstration. So today's demonstration is just on a landslide. So for today's demonstration on a landslide, we're just going to show quickly how landslides are actually extremely dangerous and they can cause massive destruction. So for this demonstration, we're going to be making our own landslide just to show how it works. So in our landslide, of course, in every landslide, we have our land, which is our bottom, our soil, which holds it packed together. So I have a bunch of soil here. And what I'm going to do is I'm going to put it in our box, in our area here. Now, the only difference is that I'm going to make a slope on one side. So right now, I made it all flat, completely flat. But what I can do is I'm just going to make a slope on one side. There's still going to be soil on the bottom, but it's going to be a very high slope on one side. Hope you can see that that slope is pretty intense because with a big slope, we're able to see that landslides can actually cause in different slope levels. So I'm just going to start off with a very average slope. It's pretty big on one side compared to the other side. Yes, I'll stop my virtual background. Okay. So now what we're going to do with our slope here is we are going to make it look like earth, like a slip, like a landslide. So we can start by putting some plants. So I picked these plants from outside. They're just a couple of weeds, so that should be okay for our demonstration. Not harming our environment too big. So I'm just going to put some of our plants in some areas. I mean, sure, it doesn't have to be straight up, but we're just going to keep it so that it does stay nice. Okay, so now that I have a plan, I'm also going to add a couple of structures. So I just made them out of paper. Doesn't look like much, but it's just to represent houses and buildings. Not that big. And with our structures, looks like this after all of that. So I have a couple structures and we have our little land. So on a mountain, if you do live on a mountain, make sure you're careful, extremely careful. So now that we have our mountain, what happens when we add water? So we have water starting off, but this water is it's clear just by looking at it. We already know it's clear water. Now, by adding water, see at the very end of at the toe of our landslide, it's pretty empty. So we'll be able to see what color our water is afterwards. Because if we pour at the start, if you can see carefully, our land is traveling and is mainly trying to level out. You see that before there was a big slope, now it's just leveled. And not only that, all of our structures have collapsed, so as our plants. Our plants have actually just moved. So they were all back here. Now if they move forward, so has our structures. And our land is a big important thing on this because we can see that before it used to be a slope, but now it's just leveled out. That's what land does. That's what it does, because from there it takes this rocks and debris and moves it to the bottom. Now I'm just going to quickly pour out some of this liquid at the end so we can quickly see what color it is. Okay. So before it used to be perfectly clean. Now it's extremely murky and dirty. And why that is because that just proves that that in a landslide or mudslide, it takes trees, it takes soil, and it moves it anywhere. So it moves it all the way down from the start to the toe. And just by knowing that, we can clearly imagine that if a mudslide or landslide occurs in real life, what will happen is very destructive, and it can destroy every house and trees in its path, which we found out by our trees. So we even have a couple of our tree debris in here too. So that was today's demonstration, so that you guys could understand a little bit that landslides and mudslides are extremely, and avalanches of course, are extremely dangerous and can be fatal as well. Okay, everyone, thank you for joining today's lesson. I don't have a poll for you guys today, but I will have one tomorrow. Thank you everyone for joining once more, and I'll see you all tomorrow. Bye guys.